Hello all, myself Dr. Achal Kaushik from Computer Science Department, Bhagwan Parshuram Institute of Technology. Today's topic is memory organization. We have already discussed in the previous unit about the basic components of the computer. That computer is basically divided broadly in three categories. One, CPU, second, main memory, and third, input-output subsystems. As we know that the CPU is basically going to control all the operations that are taken care by the system. And to perform those operations, it makes use of ALU, CU, and registers. But while processing the CPU part, it requires the memory to be utilized for program and data. And for this reason, in today's topic, we are going to discuss about the memory unit, which is very important component of the computer. As we know, memory is used for storing program and data and information into the computer. Now, besides that, once the CPU performs the operation, the intermediate result and final result is also stored in the memory unit. There are various memory devices which are being used for this purpose, and these devices are ranked according to different criteria. These criteria may be the access time, maybe the storage capacity, or maybe the cost per bit of storage. Now, this access time is important and crucial because we should understand that any operation which is taking place in the computer will be taken care by the program and data. And if a CPU instruct to perform the operation, then the time required to locate and retrieve that data will be very crucial. And that's why we are actually interested in fast access for these devices. Secondly, because amount of data is stored on the storage unit, so the more the data we can store, the faster the processing would be. Thirdly, the cost would be paramount important in this concept, that if the cost of storage increases, then the overall cost of the system increases. Now, based on these criteria, we divide our memory system into different categories. Firstly, we discuss about the processor's internal memory. Secondly, it is about the main memory. And thirdly, it is about the auxiliary memory. Now, they have their own strengths once we talk about the devices which governs within these categories. If we talked about the processor's internal memory, we also call it CPU memory. These are basically the solid state semiconductor materials, and they are very high speed registers which perform the operations. The basic purpose of these registers are to provide the temporary storage area, and they are also used to pass the data from memory to the processor for the execution. Now, because they are very fast, but they are small in number. And the other thing that are related with these memories are they are volatile in nature. So because of their volatility, they are very much providing the information till they are with the power supply. Now, we can take up a simple example that if CPU is instructing the main memory to fetch the data, then it will be making use of different types of registers available for it. It could be memory address register or memory data registers. And then performing those manipulations, the CPU may be making use of general purpose registers. Then we have the main memory. They are also the semiconductor memory devices. They are also referred as the primary memory. Basically, these memory units actually communicates directly with the CPU. As what we have discussed, that data and program currently needed are being stored in the memory. So basically, any operation that the CPU is going to perform will fetch the information from the main memory. Generally, this memory is large comparing to the CPU memory, but it is relatively slower than the CPU memory. These memories are basically having the static devices, no rotating part in it, and because of that, they are faster, compact, and also consume less power. Another disadvantage with this main memory is they are also volatile memories, and that means if the power is off, then we may lose the content of the primary memory. We can take the example of the main memory is in terms of RAM and ROM. Thirdly, we discuss about the secondary memory. Secondary memories are the auxiliary memories, or they are basically being used for bulk storage. Here we are storing the information and we are transferring this information whenever required by the CPU to the main memory. So basically they are outside the domain of CPU, and CPU cannot directly access these secondary memories. They have the large capacity than the main memory, but they are relatively slower than the main memory. And the prime reason for that, they are not static devices. Either they are in the form of rotating disks or tapes. But the important point over here is that they are non-volatile memory. That means there is no issue with these devices in terms of storage of data. Even if the power is off, we can still access those data at the later stage. These devices may be the magnetic devices or they may be optical devices. In case of magnetic devices, we may have hard disks, floppy disks or pen drives, or in terms of the optical memory, we may have the compact disks, CDs, DVDs, etc. Now, if we just summarize before proceeding further, then we should realize this aspect that to perform any operation on the computer, it is the CPU which is going to instruct to get the data from the main memory for the processing. But at any point of time when main memory respond to the request of CPU, they have speed mismatch because CPU executes faster than the main memory, and because of this speed mismatch, there is always overall system speed reduced and the performance degradation. To make out with this speed mismatch, we make use of cache memory. These are special high-speed memories and they are present generally between CPU and the main memory. If we just look up any execution, then the computer, when performing a particular program, may be accessing a website or maybe executing any application, maybe on word processing application, then first it has to search for that program and data into the CPU memory. But CPU memory, as its size is very small, it cannot accommodate all the data, and if it is not available with the CPU memory, then the CPU will be searching out the relevant information in the cache memory. Cache memory is the memory which generally keeps the data which is being used for the execution purposes. Now, if the data is not available with the cache memory, then the next step would be CPU will be accessing that in the main memory. If the data is available with the main memory, then it will be fetched to the CPU memory and the execution will take place. But in case the data is not available with the CPU, then the instruction will pass on to the secondary storage devices and the data will be fetched to the main memory for the execution part of the CPU. And that is how we execute the different aspects of the memory devices and their importance in the computer system. Now, since we have the many devices which are being used for the memory unit, so there is a memory hierarchy which consists of all these storage devices used in the computer system. Now, since the CPU registers are the first level for storing and also they retrieve information inside the CPU, then the typical memory hierarchy starts after that from the cache memory, main memory and the secondary memory. So there are different parameters based on which we can classify this memory hierarchy. The cache memory, it is small, generally in terms of few megabytes, but they are expensive. But since they are relatively very fast unit, so CPU is trying to first access the cache memory to mitigate any speed difference with the CPU and the memory. Secondly, we have the main memory. If the data is not available with the cache, then in the hierarchy, CPU will be accessing the main memory, which is larger in comparison to the cache memory, but it is less expensive and relatively slow than the cache memory. And lastly, we have the secondary memory. If we need to access large amount of data which cannot be accommodated in the main memory or the cache memory, then we have to go alone and access the data in the secondary memory. It is relatively less expensive and it is slower than the other memories. Typically, we may use the hard disk and tape for the bulk storage devices. Now, if we look up this memory hierarchy, then we understand that based on speed, we can classify these memories, or based on access time, we can classify, because all these parameters like size, access time, cost and speed are interrelated with each other. Now, in this term, let me quickly go through with the basic storage fundamental that defines that how we are storing the information in these memory units. As we discussed that the main memory is the one which keeps the data in terms of information or in terms of program. Now, whenever we talk about the processing of this data, they are stored in the computer system through the presence or absence of electronic or magnetic signals. Now, basically these are like any switch we have for on and off. Similarly, we have these devices storing these information in two states. That is the binary representation of data. If we just talk about the transistors or other semiconductor circuits which are being used for the main memory, then they are storing these information either through the conducting and non-conducting states, which are represented by 1 or 0. Similarly, if we are talking about the magnetic media, then we are using the magnetic disc or magnetic tapes. Then these two states are represented having magnetized spots whose magnetic field may be one of the two polarities. Now, based on those polarities, again, we would be storing the information as 1 and 0. So, primarily, these electronic circuits, like we talk about RAM, the conducting is on state, which is representing the bit 1 or the number 1, and the non-conducting, that is the off state, represents the number 0. Similarly, for magnetic media, the magnetic field of a magnetized spot in one direction represents a 1, while the magnetism in another direction represents 0. Now, if we look at it further, then we try to understand the basics of all computer are the primary or internal storage. Now, within these storage devices, all the data and informations are stored in the form of binary bits that we referred as zeros and 1. That is also the smallest element of data called bit, which can have a value 1 or 0. But if we summarize that at any point of time, these two states cannot define all the characters and numbers, and for very that reason, the computer codes such as ASCII, which is American Standard Code for Information Interchange, uses various arrangement of these bits to form or represent different number systems or the letter and alphabets. Now, these are generally the combination of 8 bits, and these 8 bits are referred as 1 byte. That means if we have to represent any alphabet, then it can be stored in the system by virtue of taking 8 bits together. Now, as what we have discussed, that memory devices, let it be the main memory in terms of the semiconductor devices or the magnetic devices, they are keeping these informations in the form of large number of cells, and where each cell is capable of storing 1 bit. That means to store a large amount of data, we need to arrange these large number of cells all together. So in the memory unit, these cells are organized as a set of locations, where each of these locations can store a fixed number of bits. And that is what we generally call as word length. If we just go back and see that the main memory is the one which is being directly accessed by the CPU, and that access mechanism, as you must have discussed in the previous unit, is being accessed through the address bits. Now, here the important concept is that the main memory and the CPU are related directly with these wires or these address bits, which access the information from the main memory. Now, this given memory or any given memory that what we are considering is divided into number of locations. If the number of locations are n, then these must be some power of 2. Each location is having a unique number. We call it address of that location, and through that address we can access this information directly. And there we have the concept of random access memory. That is, we can directly access any address and hence the data available at that address. So generally the address range is denoted with some number, maybe 0 to n minus 1, where 0 is the starting address and n minus 1 is the highest address available with that memory location. For example, if a memory has 512 bytes location, then the address range would be between 0 to 511. Now, if for any memory location, if we denote it by n, m being denoting the word size, this word size is referring to that how many parallel bits can be accessed by your CPU and also define the speed of your system, then the expression that denotes the storage capacity would be m cross n. Now, to extend this idea of understanding about the CPU and main memory, then we can just use this idea that the main memory consisting of memory location, that is the address, and the value, that is the data it contains. And if the CPU has to access any data from the RAM for its processing purposes, then it will be defined based on the number of address bits that will be defined through the address bus. So if we have 3 address bits available in the address bus, that will define 2 raised to power 3 access bits in terms of the address available on the RAM, and through which we can access directly the data available to that memory location. Now, if we just go alone with the basic concept what we have discussed in this particular unit, then we can summarize it in terms of the 3 memory unit divisions. One, that is the CPU memory, second is your main memory, and lastly we have the secondary memory. If we talked about the implementation of these memories, the CPU memories resides within your CPU. They are the fastest memory, but they are very small in terms of their capacity. Generally, they are accessing to the same processing capability which is being used by the CPU. They are very fast, so access mechanism is very fast. But in comparison, if we are talking about the primary memory, they are high speed electrical devices, but they are outside but close to CPU. They are relatively slower than the CPU memory, but still they manage the access because the direct access can be made, so the data can be accessed to the CPU from the main memory. And lastly, we have the secondary memory, which are low speed electromagnetic devices or optical devices, but they are primarily being used for bulk storage. Now, if we just visualize in terms of the uses of the content, the CPU is accessing the CPU memory for processing the immediate instructions, but the data if not available on the CPU memory, then we have to access it through the main memory. So basically the current running program and data are stored in the main memory. But at any point of time, because of the limitation of the space on the main memory, there is a possibility that the CPU is accessing for a particular information that is not available with the main memory. Now in that case, the current running program and data that is not properly fit in the main memory is actually being stored on the secondary device. And here we have the concept of fetching up the information from the secondary device to the main device, and this process will be repeated based on the amount of data required for the processing. And there we have the access mechanism, which is we call this to be slow side for the secondary memory. And as what we have discussed, that the CPU memory and the primary memory, both of these memories are volatile, and sometimes some portion of the primary memory is also being non-volatile. That is, we need to be very careful while making use of this data, as if the power supply goes, we may lose out the data information. On contrary, if we are using about the secondary memory devices, they are mostly non-volatile and they are being used for bulk storage purposes. Access time, if we look at for the CPU memory, it is very fast in terms of few nanoseconds. But if we talked about the primary memory, now it is hundreds of nanoseconds. It may go alone based on the type of primary memory we are using. But in case of secondary device, they are relatively slow and they generally take of the order of millisecond time. Now, this is what we have, the basic memory organization for the systems, or the computer system. Thank you.